In 1912, inside a small steel workshop in Sheffield, England, an engineer named Harry Brearley faced a problem that troubled the entire industry. Gun barrels were wearing out far too quickly. Each shot was a miniature explosion. Temperatures inside the barrel could exceed 2. Come get. And after only a few hundred rounds, the steel began to crack, erode, and rust. Brearley was tasked with finding an alloy capable of surviving such extreme conditions. For months, he tested hundreds of formulas adding carbon, reducing nickel, adjusting manganese ratios, but every result seemed like a failure. Then one day, among a pile of discarded metal left outdoors, he noticed a sample that remained bright, despite weeks of rain. When he examined it more closely, he discovered it contained more than 12% chromium, a proportion considered wasteful at the time. Brearley did not realize that he had just stepped into one of the accidental moments that would shape the 20th century, the birth of stainless steel. The 19th century was the era of steam engines, iron bridges, and railways, and also a time when metal corrosion became a global nightmare. As the Industrial Revolution accelerated, millions of tons of iron were extracted from the earth, melted, and forged into warships, bridge columns, pipelines, and factories. Yet iron, by its nature, constantly longed to return to its original red ore state. Engineers understood this, but they could not stop it. They coated surfaces with oil, painted them, plated them with zinc, yet every solution was only a delay.
This grade of
Rust
stainless steel
crept
is
through
absolutely
welds and
rustless,
screw
guaranteed
holes,
for life. Rustless, you say? How
destroying
does it hold up
structures
against
from the
saltwater
inside
exposure?
out. In London, iron bridges collapsed due to corrosion. At the ports of Liverpool, steel ships rusted within months at sea. The military suffered even more. A cannon weighing several tons could become useless simply because its barrel oxidized. Meanwhile, the demand for an immortal material grew urgent. The world was entering its first era of globalization driven by trade, warfare, and machinery. Yet everything stood upon a metallic foundation, slowly dissolving day by day. This paradox made 19th century metallurgy resemble a hospital, constantly treating symptoms but never curing the root cause. In August, o 1913, at the Brown Firth Research Laboratories, Brearley was testing new alloys for the weapons industry. He carefully recorded each sample zero.
This
24%
disc has been
carbone.
exposed for months, yet shows
8%
no
chromium.
sign of rust.
Heated to 1.
Extraordinary.
Boom direct.
While the
On
competitor
paper,
blade shows significant rust
the
and
result
pitting,
read,
our proprietary
no
steel resists
significant
corrosion
improvement in
completely, maintaining its
durability.
mirror finish.
But what his scientific eye did not immediately notice, time quietly revealed, while other samples turned reddish-brown with
steel.
rust. The chromium-rich piece remained mirror-bright. Brearley was puzzled, no reaction, no sign of oxidation. He
This
sent the
aluminum
sample for
alloy is the
analysis
future,
and uncovered
Theodore.
a surprising
Strong
truth.
yet light, and
Chromium
no sign of
oxide formed an
degradation.
extremely thin yet
Certainly
durable
speeds up the
layer that did
assembly,
not
sir.
flake off, like rust. It shielded the metal beneath. A
Engineering
failure in a
classification of
military
stainless steel
project had
304,
become a turning
austenitic.
point in the
Ring
history of
16, marine
materials.
grade.
Yet no one cared at first. Weapons manufacturers considered this non-rusting steel impractical, too difficult to machine, and lacking obvious immediate military value. Had it not been for a local cutlery merchant, Brearley's discovery might have vanished along with forgotten laboratory notes. Sheffield, an industrial city in northern England, was not only famous for steel, but also the cutlery capital of Europe. When Brearley introduced his new alloy to a knife manufacturer named Ernest Stewart, he did not talk about weapons. He talked about cleanliness. Traditional steel knives often stained when exposed to acidic foods or washing water. Brearley's sample did not. It resisted discoloration, remained rust-free, and kept its shine. Stewart tested it and gave it a name, stainless steel. Short, marketable, and powerful enough to open an entirely new market. At first, customers were skeptical. A rustless knife sounded like exaggerated advertising. But within a few years, Sheffield cutlery became a symbol of quality and modernity. From kitchens, stainless steel spread into hospitals, factories, and eventually the aviation industry. The irony was striking. An invention born from warfare found its true life at the family dinner table. No British housewife in the 1920s imagined that the spoon in her hand had once been a byproduct of a gun barrel experiment. Yet the demand for hygiene and aesthetics saved an entire scientific field. 2 decades after Brearley's discovery, the world plunged into chaos. The Great Depression, followed by World War II. When war erupted, nations needed materials that were strong, lightweight, and resistant to corrosion for warships, aircraft, and jet engines. Stainless steel became a strategic material. Different grades emerged: 304 for food industries, 316 for marine environments, 410 for knives and medical instruments. This was not just technology, it became a shared language of global engineering. A 304 standard in Germany meant the same thing in Japan or the United States. That standardization unified the global metal supply chain in a way no material had achieved before. In architecture, buildings like the Chrysler Building, 1930, and later structures such as Cloud Gate became symbols of stainless steel's beauty, bright, reflective, and seemingly timeless amid polluted cities. From war to peace, from operating rooms to restaurants, stainless steel redefined the meaning of permanence in the physical world. When philosophers speak of the Iron Age, they describe an era of raw strength. But if today's era needs a name, perhaps it is the age of stainless steel, a time when humanity first learned to restrain the decay of its own planet. Brearley's invention did not begin with the ambition to conquer the world. It began as a modest attempt to solve a small technical problem. And in that, science reveals its true nature. Progress does not always come from genius alone. Sometimes it comes from curiosity strong enough to look again at a forgotten piece of scrap. Stainless steel is the product of an age that blends reason with chance. It symbolizes control humanity, learning to harness oxygen, while also proving that every great invention carries a trace of nature's luck. Today, when we hold a polished knife, we are touching a mistake transformed into a miracle, a reminder that sometimes, to create something that does not rust, we must be willing to let experiments fail.